In this video, I will talk about branching and merging in Git, which are really its star features. Up to now, we have looked at a project with a single branch, the default master branch. All new commits are just added in a successive chain. However, there are cases where you might want the project to have multiple tracks. What are some examples of such cases? Well, let's say you are working on a paper in LaTeX. You have used Git and only the master branch throughout the project. You have written the paper to be submitted to Nature, for example. However, you're not really sure whether it will be accepted there. So after submission, because you don't want to waste time, you begin working on the paper to format it in accordance with the Actamat layout. This is not really an update of the Nature layout, and it wouldn't make sense to add this to the linear chain of history. If it turns out that Nature does accept the paper, you have to turn back the clock. It makes more sense to create a branch in the project, which runs parallel to the Nature paper branch. In this branch, you change the paper according to the Actamat layout. If Nature accepts your paper and asks for revisions, you just switch back to the Nature branch and continue working there. You might even find a way to merge some of the changes from the Acta branch into the Nature branch later. Another example is software. Let's say you have a pretty stable piece of software, but there are still some bugs we want to address. If you go in and mess directly with the master branch, you may make it stop functioning. Since the bug fix is not critical, it's better to make your changes in a parallel bug fix or development branch. Then, when you are sure the software still works, you can merge the changes onto the master branch. So your software stays stable and clean on the master branch while you mess with it on other branches. There are many more use cases for branches and many ways of organizing this in your projects. Only experimentation experience will make it more intuitive. So how does Git actually handle branches? In Git, branches are actually implicitly defined. A branch is basically just a label stuck to the last commit of a chain of commits, which can be traced back to the original commit. The branch information is stored in the commits themselves. Each commit stores its parents, which are the commits it originated from. For most commits, this is just the previous commit. But as we shall see for merge commits, these commits have two parents. If the head pointer points to a branch label, then new commits will be added onto this branch. So in our example from the last video, let's say we create a new branch called br2. It will be created where head currently is, so it will coincide with the master branch. If we now check out br2, we can make commits onto the br2 branch. For example, if we make two more commits, commits 4 and 5 will be on the br2 branch. The master pointer stays behind, and so the master branch stops at commit 3. If we now check out the master branch again, the head pointer moves there. And if we now create new commits, we will start from commit 3 and follow the master pointer. So in this way, two diverging lines of history are created. We can show this in practice on the same example we worked on in the last video. Let's check that head pointer is pointing to the last commit on the master branch with Gitlab. We are not, so we change back to it with git checkout master. Now we are on the last commit, as you can see with git log. Now we create a new branch called br2 with the git branch br2 command. You can now see with git log that br2 is also pointing to the last commit. If we now check out br2 with git checkout, we will be on the br2 branch. You can see this when you type git status. You can also see it with git log. Head is now next to br2. Okay, now let's start making our changes to the files and making some new commits. Let's add yellow star to file 2 and change purple triangle into green triangle in file 1. We will add our change to file2 to the index and commit. Remember to add a descriptive commit message. Then we will do the same for file1. If we now check the commit history with Gitlab, you can see head and br2 have moved up the chain, while master stays behind. We will now go back to the master branch with git checkout master. You can see that file2 is again empty, and file1 contains purple triangle. Okay, let's now add pink heart to file2. We'll save that. Now we add file2 to the index. Suppose we want to stage all files with changes simultaneously. We can actually use the capital A modifier as a shortcut on the command git add. We commit. If we now check the commit history with Gitlab, you will only see the master branch and not the commits we made to the br2 branch. One way to visualize the diverging histories is if you use the modifiers --all, --graph, and --one_line. All shows all the commits on all branches. Graph shows the relationship between the different branches with these lines and node symbols, and one line shortens the output for each commit. The commit is represented with a shortened identification number and the commit message. Any pointers that may be attached to the commits are also shown. The output shows that the master branch and the br2 branch are now following different lines in history, diverging from the third commit. Sometimes different branches never come together again. This can be considered a fork. The branches develop into different projects. But many times a branch is created temporarily, for example to fix a bug. But there are many other reasons you might not want to commit directly to the master branch. Then at some point you want to merge the changes back into the master branch. So how does Git do this? There are three main ways Git can merge branches back together. And luckily Git is very smart about this. The easiest merge is when the two branches are still on the same chain. In this case, one branch label is simply ahead of another branch label. So all Git has to do is move the branch pointer along the chain, and the branches are merged. More difficult is when we have two diverging branches, as in our example from before. To merge these branches, Git will try to create a merge commit. In order to decide what to put in this merge commit, Git compares three commits: the two commits to which the branches are pointing, and the latest common ancestor of the two branches. The default merge behavior is that Git tries to merge all the changes and additions from the common ancestor. So for file1, for example, it will see that in the common ancestor we have a purple triangle, and this is the same in the master branch. However, on the br2 branch, we have updated this to a green triangle. For the merge commit, Git considers the green triangle the desired updated version, and this will be selected for the merge. If we would have added a new file in one of the branches, then this will be added in the merge also. For file2, we will encounter a problem, because in the common ancestor file it was empty, but in both branches we have made different changes to the file, so Git cannot decide which one should take precedence. Git will indicate a merge conflict has occurred on file2 and will mark this inside the file. You will have to manually edit the file and create a merge commit. This will be indicated by the Git error messages. Of course, this is the default merge behavior, but one has a lot of options to change this. Maybe you want whatever happens on the master branch to always take precedence over other branches, in the case of merge conflicts. All the details of merging will not be discussed here. For that, I refer you to more detailed literature. Also note that in this case, our files are very small and we only have one line. But in large files with multiple lines, Git is smart and will find and mark only those lines where merging is a problem. A final way to merge changes in Git is with rebasing. Instead of creating a merge commit, Git tries to chop off one of the branches at the common ancestor and apply all the changes from the one branch consecutively on the other branch. Basically, a diverging branch structure is turned back into a linear structure. I won't go more into detail on rebasing, but just be aware that it exists and that there are use cases for this. So finally, I want to show you again in practice how the different kinds of merging work in our simple example. To show you fast forward merge, we will first check out an earlier commit, say commit number 2. Now the head is not pointing to any branch, which we can see with git log. We can create a new branch pointer here with git branch, and we'll call our branch br3. Now if we check git log master, you can see that br3 and master are on one chain. So we can merge with fast forward using the command git merge master. You can see that Git automatically detects it has to use fast forward, and the br3 pointer is moved to the same position as master. We can see this with git log. We don't need br3 anymore, so we can delete it. First, we check out the master branch. Then we use git branch -d br3. The -d will delete the br3 branch. You can see that br3 is now gone when we type git log. Okay, now we can try to merge our master branch and br2. Head is currently pointing to our master branch. You see that we get the message that there is a merge conflict on file 2 as expected. If you type git status, you see that there are changes to the files that are not committed. So the merge commit was not created. If we check file 1, we see that it has been updated to green triangle as in branch br2. If we check file 2, we see that Git indicates a conflict in this way. In the master branch indicated by head, we have the pink heart, and in the br2 branch, we have the yellow star. So we should edit the file to the right version. Let's say we actually want pink heart in the file. We delete everything else and save the file. Now we add all files to the index with git add -a. Now we type git commit with the commit message merged br2 and master. And everything is committed successfully. Now if we check git log with the modifiers that I mentioned previously, we can see that the branches have been merged. And we see the branch histories. The head and master pointers are on the last merge commit. br2 is still pointing to the last commit on the branch. We can now either delete br2 if we don't need it, or we can move it to the current position with a fast forward merge. Or we can just leave it in its place. It's not doing anything. A final thing I want to talk about in this video is the diff command. With this, we can actually see the differences between versions of files in different commits. To use it, you just type git diff, and then the identifier of the initial state and the identifier of the final state. An identifier can be either an ID number or a branch name. So for example, we can compare the master and br2 branch with git diff br2 master. We see that the only difference is on the file number 2, where in the master branch we have pink heart, and in BR2 we have yellow star. We can also use two commit IDs. For example, the first commit and the current last commit. We can also add a specific file to see only the differences on that file. So let's say file 1. We can see that in the second commit, file 1 was empty, and in the last commit it contains green triangle. Git diff is actually what is used by Git when it tries to merge different branches. There are many more options to git diff, so I encourage you to go and explore them. To summarize, we saw only a few new commands in this video: git diff to check differences between commits, git branch to create a new branch, and git merge to merge branches. We already saw git checkout, but I'm just repeating it here as it's quite an important command. I hope with this video the logic behind branches is clarified and you can start using them in your projects. Now you basically know everything to use Git as a pro locally on your own computer. In the next and final video, we will talk about remotes, Git on a server, and collaborating on the same projects with others. Thanks for watching.